Okay, welcome back. We're going to do some applications now with these linear functions. Um, Here's a word problem, and I just want to kind of quickly go over what my strategy is when I encounter word problems like that. And it's these basic 5 steps. First, I'm going to read carefully. Then I'm going to draw a picture, and this is kind of a visualize step. I want to visualize myself in the problem, what I would do if I was in that situation. Then I'm going to generally write an equation or some numbers down or something like that, and then I'm going to solve, and then I'm going to check my answer to make sure that I answered the question. Okay, so reading carefully, Sam wants to take his MP3 player and his video game player on a car trip. So now I'm already starting to visualize, yeah, it's like something I would do. I'm going to go on a car trip, and then I need to charge my video game player and my MP3 player. Okay. An hour before they plan to leave. So this is, when I see an hour, that's kind of something I would circle. That's a value. That's 1 hour, right? Before they plan to leave, he realized that he forgot to change the batteries last night. Yep, I do that a lot. At that point, he plugged in both devices so they can charge as long as possible before they leave. So that's what okay, so he's charging both devices. Okay. Sam knows that his MP3 player has 40% of its battery life. So this is kind of where it's starting out, right? And that the battery charges by an additional 12 percentage points every 15 minutes. So now I'm thinking, okay, it's going to go up by 12 every 15 minutes. Okay. His video game player is new, so Sam doesn't know how fast it is charging, but he recorded the battery charge for the first 30 minutes after plugging it in. Okay. So it's this table. So at 0, the video game player was 20, then at 10 minutes it was 32, 20 minutes, and so on. If Sam leaves as planned, what percentage of battery life will be charged for the 2 devices when they leave? Okay. And how much time would Sam need to charge the battery 100%, or need to charge the battery to 100% on both devices? Okay. So now let's draw a picture. So we have these 2 devices. We have MP3 and video game, and they're both charging. Okay, and then it says that the MP3 player is at 40%. So it's starting out at 40%. And then the video game player, actually, he did in this table, at 0 time, it was at 20. Okay. So I'm starting to picture and visualize what the problem is. Okay. Now, I think about, let's write some sort of equation, or actually probably a graph would be a good idea. Or we could do a table of values. We already have a table of values for the video game player. Okay, so let's write down a table of values. So this is for the MP3, and this is for the video game. Alright, and so video game we already have, so this is T and this is percent. T and percent. Alright, so it was 0, 20, 10, 32, 20, 44, 30, 56. And over here in MP3 it says it started at 40, so 0 times 0 it was 40%. And then each time it's going to increase by 12 percentage points for every 15 minutes. So the next time would be 15 minutes, it would be 12 more, which is 12 plus 40 is 52. Okay. Now I could keep going with this pattern all the way to 1 hour, right? That would be a strategy to solving this, right? That's one way you could solve it. Another way would be to write a symbolic representation of how much charge there is based on the time. And another way would be to make a graph, right? So I think the way I would probably do it is to make an equation. So we have video game charge equals, what is the rate of change? So for every 10, so every time I add 10, I add 12 for the video game. So the unit rate of change would be change in y over change in x. So 12 to 10. Okay, equals t plus, it started with 20. So that's my initial condition. Alright, so if I go to t equals 60, alright, 60 minutes, then I should get my answer. So 10 goes into 60 6 times. So I have 12 times 6 plus 20. So 12 times 6 is 72 plus 20 is 92. So at 60 minutes it would be 92% charged. Alright, so that's one answer. The MP3 player, let's see, it starts out at 40, so my MP3 as a function of time, my rate of change, let's see, it goes up by 12 for every 15, right? Up by 12 for every 15. So my change in y is 12, and my change in x is 15. So my slope of my line would be 12 to 15. I could reduce this to get the unit rate of change. Let's go ahead and do it. I can divide both by 3. Right? So it would be 4/5. T plus, it starts out at 40. Okay? So I want to find out what is the charge at t equals 60, right? Time of 60 minutes. So 4/5 times 60 plus 40. Okay, if 5 goes into 60 10 times with 2 more, so it's 12 times. So 4 times 12 is 48 plus 40 is 88. So at t equals 60, the MP3 player has charged to 88%. Okay, so I have some answers here. Let's check, see if I answer the question. If Sam's family leaves as planned, what percentage or what percent of battery will be charged for each of the two devices when they leave? So I have my answer, 88% for the MP3 player, 92% for the video game player. How much time would Sam need to charge the battery? 100% on both devices. So I want to say, what is 100? How much time would it take, right? 4/5 t plus 40. So to solve this, I would subtract 40 from both sides, and I get 60 equals 4/5 t, and then I multiply both sides by 5/4. So it cancels to get t equals, let's see, 4 goes into 60. No, it doesn't, does it? Yeah, it does. So 4 goes into 6 one time. 4 times 1 is 4, minus 4 is 2, and 4 goes into 20 5 times, so it's 15. So 4 goes into 60 15 times, and then 5 times 17. Oops, 5 times 15 is 25, carry the 2, 20. 5 times 1 is 5, plus 2 more is 7. 75 is my time. So 75 minutes to, so 75 would be 100% on the MP3 player. And for my video game player, let's see, I would set up another equation. How about 100 equals 12 tenths t plus 20. Subtract 20 from both sides to get 80 equals 12 tenths t, and multiply both sides by 10 twelfths to make that a 1. Okay, so does 12 go into 80? Well, I could divide both of those by 2, so this is 6 and 5. And then I could divide both of these by 2, so I get 40 and 3. And then it looks like it doesn't come out evenly, so 5 times 4 is 20, so 200 thirds is t, which as a number of minutes would be, well, it goes into, I'll just divide it. 3 goes into 26 times, so we get 18, subtract 2, and yeah, it's going to be 66.6, right? Because it just repeats. Yeah, 66 and 2/3 minutes would be 100% for VG, video games. Okay, so there's my 2 answers for that, and it seems to make sense that that would be the time. Okay, so that's how you check, is just make a real world check to say, does that make sense? If it's going to be 92% in 60 minutes and 66 minutes, it would be about 100%. That makes sense. And 60 minutes to get to 88%, that kind of makes sense. And then 15 more minutes, yeah, to 100% makes sense. Okay, so that's how you do it. You go through, you read the problem carefully. I like to draw a picture, or at least visualize what's happening. Then I write the problem down, maybe a table or a graph or something like that. Solve the problem, and I check my answer.